it says scatter plot, but it doesn't look like one because it doesn't look linear. So anyway, the scatter plot on the right shows some values of fuel consumption F for the given values of engine speed S for a particular car. For the points in this scatter graph, F can be closely approximated by a quadratic function of S. RFS is the correlation coefficient between F and S. Based on the points in this scatter plot, give a reason why you might think that the RFS is very close to zero. Now remember, if my correlation coefficient is close to zero, it means that it is not forming into a line, not forming into a line. So in other words, it's not linear, and we can see here that this one looks more like a quadratic. So for those reasons, I would think that that's why the correlation coefficient will be close to zero, because it is not, in fact, or certainly doesn't look linear, it looks quadratic. 13 customers rated their experience in a garage by giving a whole number score out of 100. The mean score is 52, and the median score was 54. No two scores were the same. Okay, so we've no repeated values here. The table below shows the score for each of the 13 customers in no particular order. Stephen gave a score of S and Mary gave a score of M, where S and M are elements of N. In other words, they're whole positive numbers. Find the least value and the greatest value that S could be. Okay, so we're missing two values, but we do know what the mean is. So I guess if I was to add up all the scores that I can see, plus my S and N, I would divide it by 13, and I'm supposed to get an answer of 52. So that's probably not a bad place to start. So on my calculator, I'm going 46 plus 68 plus 24 plus 74 plus 42 plus 30 plus 61, 54, 28, 50, 57. So that's as much as I can find out. So that's 5, 3, 4 plus S plus M. So they're all of them that add to 52. Now, I'm going to multiply 52 by 13 because that will then give me, you know, I'm cross multiplying basically. So that's give me 676. And then if I want S and M on its own, I bring that guy over and I subtract 534 minus 534. So what I know at the moment is when I add the two missing scores, I get 142. Now that's still no good to me really, because I still don't know what S is or what M is for that matter, but it's S in particular that I'm looking for. So now I'm going to turn my attention to the median. Now the median means they have to be in order. They're not in order in the table. So what I think I'm going to do is I'm going to go through them and write them in order. So I'm going to start by looking for my lowest number. I think that is 24. So if I do 24, then the next one I think is 28. 30 looks like it will be next. 42. 46. 50. 57. No, 54, sorry, is next. Then 57, my mistake. Then we have 68, and then we have, no, we have 61, then we have 68, and then we have 74. Now, we still haven't done anything with the S and the M, but just let's look at this first. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So it's 13 people, 11 that we know of. Now, we are told that the median is 54. So just looking out of 13, we should have 6 on one side, 6 on the other, and then the 7th should be the median. So let's see what we have. 1, 2, 3, 4, 5, 6, 7. Now, at the moment, the way, after putting them in order, 54 is bang on in the middle. So that would suggest that the number that I'm missing, well, the smallest it could be, I guess, would be the next number, 55. So the smallest it could possibly be, it can't be smaller than 74, because otherwise it would change the median. So the smallest it could possibly be would be 55. Now, if that was 55, well, then the other value would be, well, the other value would be M, but remember M and S, we don't know which is which. They've asked us just to concentrate on S, but ultimately we know if you add them together, you get 142, sorry. So what I'm going to do is I'm going to do 142 minus 55, because that should give me my alternative answer, because there's two of them missing, and the other answer is 87. So the biggest it could possibly be is 87, and then M is going to be the other one that we haven't spoken about. So I suppose if S is 55, M is 87, and if S was 87, then M would be 55. Okay, what's left in this? Okay, well, just a quick look at this. If the head gasket blows, John will have to replace his car at an estimated cost of 20,000. If the head gasket is replaced now, it will cost 1,450, and the probability that it blows in the next year will be reduced to 0.005. Based on these figures, use expected value to work out if it's worth replacing the head gasket now or not. Now, expected value is usually the one we use when we're, when we're playing a game and we want to see if it's worth playing. So that's where we come across expected value a lot. But here we're just basically saying, okay, there is a 0.095 chance the head gasket will blow, and if that's the case, it's going to cost 20,000. So if I multiply that together, 0.095 multiplied by 20,000, it's coming out to be 1,900. So on average, I guess I'm expecting to pay 1,900. Now, if he replaces it now, well, then I can expect to pay the 1,450, which is what it will cost. But I still have the risk that it could blow again, but the risk is obviously much lower. In fact, it says it will go down as far as 0.005. So this time, if I multiply that by the 20,000, I can now figure out what on average we expect it to cost me. So I'm just putting it into my calculator, literally just as I see it here in front of me, and 20,000. So that's coming out at 1,550. Of course, it's still a lot of money, but the conclusion is really, I guess, that he should replace it now because it's cheaper to do it that way, working out the probabilities. Finally, it says, work out the probability that at least one of the events in the table above happens to John's car this year. Now, if it's at least, it means he could have all three problems, two of the three problems, one of the three. In fact, the only thing it wouldn't have would be none of the problems. So what we'll do, I think, is have a look at it not happening, because it's actually easier. Instead of looking at least one, the best thing is to do, let's look at it not happening at all. So up here, I'm going to write all the alternative probabilities. So the fact that the probability that it could blow is 0.095. So I'm going to do 1 minus 0.095. So the possibility that it won't blow is 0.905. I'm going to do the same for the next one, 1 minus 0.041. So the probability nothing will happen is 0.959. And for the last one, the probability of nothing happening is 0.927. Now, they're all the chances that nothing will happen. So what I really need to do is I need to multiply those together to give me, that would be my fundamental principle of counting, of nothing happening. So if I multiply these together, it's the probability of nothing happening. So this is my probability of nothing going wrong, 0.905 multiplied by 0.959 and 0.927. Now, when I do that, I get 0.804538, etc. Now, this is the probability of nothing happening. So it's the opposite really of at least one thing going wrong. So I'm going to now do 1 minus 0.80453. So that comes out to be 0.19547. Does it say replacing or correcting to 3 decimal places? So 0.195, and we're done.